In this example, we're going to learn a little bit about integration with respect to y. So far, almost everything we have integrated has been in regards to our independent variable, or with respect to our independent variable, x. So sometimes it's easier to integrate with respect to y. And it really works the same way, especially if we have a region bounded by two curves. But instead of defining our interval along the x-axis between some a and b, we're going to choose a c and d value on the y-axis. And you see that illustrated in these pictures here. Okay? And so we will think about them as being a function x in terms of y. So if we rearrange the way the function looks, instead of having y in terms of x, we rewrite it so that we have x in terms of y. We can integrate with respect to y. And if we have two curves and we wanted to find the area between those two curves, instead of upper minus lower, it's going to be right minus left. It's always going to be the curve on the right minus the curve on the left. Okay, and so notice here when we think about this area formula, we have a C and a D as our bounds. So let's look at a specific example, and this specific example is going to directly reference the video or the example we did in the previous video. So let's think about this. If I asked you to find this area, the area of this region in quadrant 1, the way we did it in the last video, we had to say above minus below. But of course the above and below were different based off of that horizontal x interval. From 0 to 2, we had to do square root of x as the above function minus y equals 0 as the below function. And from 2 to 4, we had square root of x as my above minus x minus 2 as my below. So we had to break that into two integrals. However, if we rearrange this and we think about integrating with respect to the y-axis, that would change my bounds from y equals 0 to y equals 2. So this would be the integral from 0 to 2. And we would have our green, because that's on the right, that's the function on the right, minus the red, which is the function on the left. So if you think about tilting this and turning this 90 degrees counterclockwise, we would see that above and below. Okay? So the only thing is that these bounds here are in terms of y. So we are going to be integrating with respect to y. And what that means is I need these two functions to now be written in terms of y. So y equaling square root of x, I could rearrange that and say, well, that is the same as x equals y squared. And similarly, y equals x minus 2, that's the same as x equals y plus 2. So, if I think about it that way, I have x equals y squared and x equals y plus 2. So what that means is my right and my left function, my right function would be y plus 2, and my left function would be y squared. So we would integrate in that regard, right? So my variables are all in terms of y. I'm integrating with respect to y. And my bounds, my limits of integration, are on the y-axis. And you can see in this setup, as opposed to the one from our previous example in the previous video, that I did not need to set my integral up as two separate pieces, right? So just minor modifications at the onset can create a much simpler integral for us to solve. Now, in the example from the last video, we got 10/3 as the area. We're going to get the same area here. So let's evaluate this integral, right? So this is my area. So area is the integral from 0 to 2 of y plus 2 minus y squared dy. And this is very simple to integrate. Y becomes y squared over 2. 2 just becomes 2y, and y squared becomes y cubed over 3. So we're going to need to evaluate this from 2 to 0. I'll plug in my 2 value first. 2 squared over 2 plus 2 times 2 minus 2 cubed, over 3. Minus, we'll plug in 0, and when I plug 0 in, I'm going to get 0 for all of these terms. 0 squared divided by 2 is 0, plus 2 times 0 minus 0 cubed over 3. So all of that goes to 0. And simplifying this, we would get, I have 4 over 2, which is just 2, plus 4 minus 8/3, which simplifies, and we get 10/3 as our solution. 6 minus 8/3 is 10/3. So you see we get the same exact answer as what we did in the previous video, the previous example, but our calculation was much shorter. And this is really important, especially when we get to Calculus 2, thinking about integrating with respect to the y-axis as opposed to the x-axis. Okay, so integration with respect to y. In this class, in Calculus 1, it's not necessarily required that you do things that way, but in Calculus 2, you'll do that a lot. So make sure you understand this example.